Okay, mic check. Just checking to see if everything is okay or not. Just give me a sec. Okay, folks, I think we are live. Just checking if everything is all right. Mic check and basic stuff. Just give me a sec. Yeah, things seem to be working good. Yeah, just final minute checks. So we are just a minute away from 10 a.m. Let's wait for a couple of minutes as other people are joining in, and then we'll get started. I'm just reading through the chat session here that we have. Just confirm that I'm audible and clearly visible. Can you just confirm that on the chat? Hey, good morning, folks. Just wanted to make sure there are no glitches. Okay, you said voice is echoing. Okay, let me just change my microphone a little. Why is that so? Let me just adjust it and see. Okay, everything seems okay. Hey, good morning, folks. Thank you for joining us this early. Okay, I think, again, it's 10 a.m. sharp right now. Let's wait for a couple of minutes. We'll start sharp at 10:02 a.m. Just a couple of minutes for people to join in. I think that's a courtesy wait time that we can give everyone. So as many of you know, the topic of discussion today, is how to code effectively, and also how to build a simple web scraper. Again, if you are a very strong programmer, this session might bore you. I'm just warning you up front. If you're a good programmer who has been programming for a few years and you're very comfortable with programming, some of what I'll discuss today could bore you. But if you're somebody who is a young computer science student, or who thinks they're not very strong at programming, or in other words, somebody who's from a non-computer science background who's moving into machine learning and data science, some of what we discuss could certainly help you. And the reason we picked up this topic is we have seen a few students struggle through the assignments that we have, primarily because they either come from a non-computer science background and hence they've programmed many years ago, or that they've not programmed effectively for many years, right? Or they've not programmed extensively for a few years. So we thought by doing a session on this, again, this is going to be a very, very basic session. Remember, what we're doing is we're alternating between an advanced session and a basic session. The last week we did how to build a chatbot, right? We went through various design choices that we have when we have to build a chatbot and things like that. This week, so that was most targeted towards people who are at the later stages of the course. This week, just done Python probably, right? Of course, some knowledge, some working knowledge of Python is certainly necessary to understand today's session. And I'm hoping most students who are attending it, or most course participants who are attending it, have either done the Python course or the Python chapters in the course, or they're comfortable with Python programming in general, right? So anyway, so it's already 10:02, so let's get started. So somebody was asking about what happened to the live session app. That app is still there, just to be clear here. But we thought a general purpose session like this, which is open to everyone, not just our registered students, is a good idea, because this is a very general topic which could benefit everyone who is getting into programming, or who's transitioning from a non-computer science or a non-programming role to a programming role. That's why we thought it's best to do it on YouTube, so that everybody benefits. Basically, it's not a very specific topic that we picked up. Of course, once in a while we will do these general purpose sessions on YouTube, but in general, we will be doing most of our live sessions through the desktop app that we have for all of our registered students. So with that, let's get started. I'll just, as usual, change to the, just give me a sec. Okay, I'll simply change to the screen sharing mode, take my face away so that we can focus more on the content. Okay, I hope everything is good. Let me just check this once and then get going. Just give me a sec. Okay, I think things are good. Okay, sounds good. Okay, so this is the agenda for today. Let me. Okay, so let's just. Okay, so this is the agenda that we have for today on 23rd Feb 2019. The two topics that we'll cover, we'll try and spend about 1 hour on each of these topics. The first topic is how to code effectively. The second topic is how to build a simple web scraper. Again, please note that we're not building a state-of-the-art web scraper because that's a non-trivial task. We'll introduce you to how to build a simple web scraper using some simple code and some blogs. Okay. So before we get started, couple of anyway, I'll keep checking on YouTube also to see if there are any issues or hiccups. Okay. Okay. So okay, I'll also take a couple of breaks in between so that I can go through the comment section and try and answer some of the questions. Okay, so a few announcements before we get started is primarily targeted towards the registered students. So the first one is last week, if you recall, we have done this live session on how to build a chatbot. So I'm extremely happy to see many of our students build chatbots using Rasa, Dialogflow, and some simple chatbots that they've built using Dialogflow. Some of them have built it using Rasa. Some of them even attempted the end-to-end conversation engines. And this is very encouraging. This is like feedback for us that the session we did is certainly very useful, right? So thank you all. Thank you all. Thanks to all the students who have taken up time, who have catered time to do this. And we strongly encourage our students to take the lessons that you learn from these live sessions and work on top of them so that it gives us constructive feedback on how we can constantly improve the course, number one. Number two, it also keeps us motivated and encouraged when we see great results like this. The second is, sorry, today is a Saturday event. We typically do Sunday mornings, 10 to 12. This week I'm traveling tomorrow and I wanted to do this session without canceling it this week. Hence, I thought we'll do it on a Saturday. I understand that some people, because they're either college-going students or working professionals who have to go to work on Saturday, they might miss this. Apologies for that. But this whole session would be available on YouTube so that you can just watch it after your college or after your working hours at office. Okay. Sorry for a Saturday event. We'll try and consistently do most of the sessions on Sundays, unless there are other constraints, like I got to travel tomorrow. Okay. So the third thing is we'll be having a new website in the next week or so. We have built most of the key components of the website. We have also tested it fairly decently. And we will have some downtime, mostly night hours IST. We'll announce it upfront. So if you have any downtime, maybe one night or two nights this week, apologies for that, but we'll inform you well in advance. This is to transition everything from the old website. Of course, a lot of our students have given us feedback on how to improve the website. Some of this feedback has already been incorporated into the new website, right? And the new website is certainly way faster than the old website. So we re-architected the whole system, wrote every line of code from scratch, just to ensure that it will be faster, it will be seamless, and things like that. But we would need some transition time to pull out all the data from the old website, move it to the new website, etc. But we'll make announcements. We'll make an announcement of downtime during night hours IST. Sorry to the folks who are in daytime, who are in US and other time zones, who may observe this downtime during day hours for you. Apologies for that, but we had to pick one set of users over other, unfortunately. And since many users are from India, we thought let's do it during night hours India time, right? So apologies and please cooperate on this front. Once the website is up, We will start a new Slack channel to report any bugs and improvements to the website so that our tech team can fix them one by one. Of course, it will take some time to fix all of them, but slowly and steadily, we'll start this new Slack channel. Of course, all of our registered students would be able to access the Slack channel and give us constructive feedback and report bugs and things like that, so that we can fix them and iterate and get to a better website as fast as possible. Okay. So the other major announcement is that we will be putting out, this is again for registered students, because some registered students have asked us that because of some work constraints or other constraints, if they're not able to attend a live session while it's happening via the desktop app, could they get access to those videos? So we will be putting out the live sessions in the desktop app only for registered students 24 hours after the completion of the live session, right? So we'll have a 24-hour buffer period so that people who could not attend these live sessions in person could certainly watch them 24 hours later via the desktop app. Okay. So we got a lot of feedback on this front, and we thought this is certainly a logical request. Of course, but we certainly encourage all of our students to join us during the live session, because it gives us a nice framework to interact, right? It gives us a very nice framework to interact and to get your feedback and to answer some of your questions and things like that. Okay. After those announcements, let's go into how to code effectively, right? This is the key topic. Of course, there are a couple of subsections here. So I'm assuming here, the big assumption that I have is that you already have decent knowledge of Python. All the course participants, I'm assuming that you have gone through all the chapters of Python. So you understand what is a variable, you understand if-else conditions, you understand for loop, you understand functions. Okay. I'm not expecting you to be the basic constructs, right? The basic things about variables. I'm assuming that basic if-else conditions, basic for loop, while loop, right? Also some basic things about functions in Python. Similarly, concepts like recursion, right? Concepts like modules, etc. Right? I'm assuming you've gone through some of these Python chapters and you have this foundational knowledge. I'm not expecting you to be an expert in any way. Okay. So the first question, so before we go into it, what is the objective of this session on how to code effectively, right? So I think after talking to a lot of students, also reviewing many assignments, these are the problems that we faced and we want to help you fix them. First thing is, given a problem, given any programming problem, the first task is to break down the problem into smaller pieces. Break down the problem into smaller, manageable pieces, right? That's something that many people are not able to do. Of course, I'm not expecting that everybody would be able to do it on day zero itself, but I want to guide you in the right direction on how to break down a problem. Also give you a lot of practice problems so that you can build on top of it. The second thing is the core concept behind Applied AI course itself, which is to learn, right? No course on earth can cover everything and all the things, right? Obviously, it's impossible. So what we would cover in Applied AI, even Python content, right, in Applied AI course, what we have done is we have limited ourselves to the very basics and techniques that you need for data science and machine learning specifically. There are lots of parts of Python that we did not cover intentionally, because this is not a Python course. So, and there are some concepts in Python and some libraries in Python that we have introduced as and when we need them, right? So we want to encourage our students to learn using Google, using function references and things like that. And there's a third thing that we observe a lot amongst our students, which is many students have fear of using new libraries. Okay, if you see a new library, let's say, right, people say, okay, I don't know what this library does, I'm not sure what it does, and they start getting frightened about it, and they don't even use it. So I want to demystify some of these things. That new library, what is a new library or a new module? If you think about it, it's basically a bunch of classes and a bunch of functions that you care about. That's all there is, right? In a nutshell, this is what a new library is all about. If you know basics of classes and functions in Python, learning a new library is just about Google searching for a bunch of classes that are useful for you. So I see a lot of fear among students especially the non-computer science students and non-experienced programmers to use new libraries. So what we will do here is we will focus on all these three things. Of course, there is obviously a lot of experimentation that you have to do. There is search, and you have to learn, and you'll fail. Trust me. I started programming, I think, when I'm in 11th class. So because I was studying in CBSE syllabus when we had programming. I still remember the very first few programs I wrote. I struggled through them, right? It is only after a while that I actually got comfortable with programming, right? I think I started in Fox Pro. I think there is this thing called Fox Pro, and I also learned C++. Probably in my 11th or 12th grade. Of course, I don't know what a class is and things like that at that point of time. Very basic understanding, but I knew what a for loop is, what an if else condition is, and stuff like that. But it took me quite a while to get a good grasp and to become a decent programmer who can write decent programs. Right? It's not like a switch that you turn it on and you have answers. It's not like that. It'll take a lot of practice, to be honest with you. There are no shortcuts here. As always, anything that is useful skill to learn in life would not have shortcuts. If there was a shortcut to learn it, then that skill is mostly useless, right? So I'll guide you through the right path, but there are no shortcuts. Let's be honest here. Okay. So let's start with, so I'll try to focus on all of these aspects. Of course, we'll introduce you to new libraries and explain you how new libraries are extremely easy to pick up. We'll also teach you how to break down a problem, how to experiment, search, debug, and learn, basically. So we'll start with some simple problems, and then we'll go to web scraper by the end of this session. Okay. So just a second. Let me see if everything is okay here on the live sessions. Okay. 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 Somebody was also asking about SQL. I'll come there. So we have actually covered SQL extensively in the course. We actually take IMDb dataset, and what we have done is we actually show you how to actually build how to use SQL in the real world data. So here is this question: how to learn SQL. There are many good sources. There is a good source called W3 Schools if you're not a registered student, which has some nice tutorials. If you're a registered student, we have a lot of content on SQL itself. We take IMDb data and show you and introduce you each of the concepts via the real world examples from IMDb datasets. Okay. Okay. So I hope there are no issues here. So I'll go back to the discussion itself. Okay. So let's start with a very simple problem. Okay. Then we'll take slightly complex problem, and then we'll jump to a web scraper. Okay. Bear with me. I'm starting very, very simple here. Some of you may think this is too kiddish, but this is how logic will be built, right? So the first problem is, okay. So the first question, so the first program is find if a number is prime or not. Okay. The moment you see this, okay, this is a mistake that a lot of people do. The moment people see this problem definition, they start coding. That's a bad habit. Unless you're a terrific coder, unless you're a brilliant coder, the first thing that you should try and do is break down this problem. The first task that you should do here is, okay, I've written it here anyway, very clearly. Write down the logic, how you would find it. Forget about code and all of that. First, write down the logic on how, given any number, if I give you a number 5, how do you determine 5 is prime or not? First, get that logic right in your head. Write down the steps. And while writing down the steps, if you can write down using concepts that you already learned. You learned about conditions, like if-else conditions. You learned about while loop and for loop, or functions and recursion, right? So basically what you're trying to do in step 1 is you're writing the logic, if possible, using the conditions that you already know, by breaking down the problem into smaller components. So we'll do that step by step. Okay. First thing. Okay. Forget about everything. Let's try to explain this in English before we even use conditions, functions, etc. Right? How do I determine if a number is prime or not? Suppose I have a number n equals to, let's say, 12, or let's say 13. Okay, 13. I want to determine if this is prime or not. What do? I take all the numbers between 2, so on and so forth, up to 12. Okay, I'm giving you the simplest algorithm. There are more optimal algorithms. I'm not even going there. Okay, so this is not about optimality. This is about writing working code as a first step. So how do you determine if a number is prime or not? What is the simplest way? You check if each of these numbers can exactly divide your n or not. So first you check if 13 divided by 2, what is the remainder? Okay, what is the remainder when you divide 13 by 2? Okay, so you see if each of these numbers 2, 3 up to 12, if any of these numbers can divide your n, then it is not a prime. Then it is not a prime, right? If they cannot divide, then it's a prime. So simply put, if you have to write the logic in English, you say if n is not divisible, if n is not divisible by 2, 3, so on, so forth, n minus 1, if it is not divisible, then n is a prime number. Then n is prime, right? Else, otherwise, forget about the terminology. Otherwise, it's a prime. It's not a prime, right? Otherwise, it's not a prime. This is how we would explain it to a small kid. This is the logic, right? I'm not even going into the code right now. This is simple logic, right? So once you got the logic right, that's what is important, right? So now you got the logic right. You got the logic right. Try to explain this logic using the tools that you have at your disposal. What tools do you have? You have the concept of conditions like if else. You have the concept of loops. You have the concept of functions. Let's just use these simple constructs. Of course, there are more ideas like recursion, classes, all of those, right? But for simplicity, let's just say using these concepts, forget about the programming language that you're coding in. Okay, if you get this part right, writing code is basically converting the logic that you got into some programming language syntax. That's all there is. Okay, so let's ignore the programming language for a while and write down. Okay, write down using these constructs. So you'll say first you want to input n. Okay, you want to input n and store it into a variable. Okay, you want to input a number. So let's write this. So n equals to input a number, right? Of course, if the number is equal to 1 is neither prime nor is it a non-prime number. So that number cannot be 1. 0, there is no point in it, right? So you want to input a number that is greater than 1, obviously, right? Otherwise, again, you want this to be an integer, okay? Not just a number, an integer. Now, once you got this, I'm just trying to be mathematically accurate here. Once you got this, what do you want to do? Okay, you want to check if n is divisible. So you want to check if n is divisible by 2, 3, 4, so on, so forth, up to n minus 1. See, the moment you want to do a check, like is n divisible by something, multiple, look at this, by multiple values here. That's what you want to do, right? So the moment you see something like this should remind you of a for loop. Because in a for loop, I can say for I equals to 2 to n minus 1. Okay, again, I'm not writing code in any language here. I'm just writing the logic that I got. For some variable I from 2 to n minus 1, including 2 and n minus 1. Okay, if n is divisible by I, right? Because now your I is taking 2, 3, 4, n minus 1. If n is divisible by I, okay, if n is divisible by I. So how do you measure if a number is divisible by I or not? There is something called as a modulo operator. You might have learned this when you learned about operators in Python or operators in any language for that matter. Okay, if n modulo I is equal to 0, okay, let me not write the C syntax here. Okay, if n modulo I is equal to 0, you would say not a prime. You would say not a prime, right? And you check it for all of them because you've already declared that it's not a prime. There is nothing else to check. For example, if your input number is 12, first you check with 2. Okay, 12 modulo 2 is 0. Now, which means 12 is exactly divisible by 2. You don't have to again check if 12 is divisible by 3, 4, etc. Now you already declared that it's not a prime, so nothing to worry. Then you exit. Okay, again, I'm not writing the optimal code, I'm writing the code that is simplest. Okay, and at the end of this whole for loop, if you have not exited, what does that mean? If you have not exited at the end of this whole for loop, what does it mean? It means your n modulo I was not equal to 0 for all possible values of I, because I is taking values from 2 to n minus 1, right? So the moment this for loop came out, the moment you exited the for loop without exiting the whole program, you can say this number has to be a prime, because I already checked it with all the numbers between 2 to n minus 1. And in all these cases, when I tried n modulo I never got 0. Very simple algorithm. Of course, this is not the optimal algorithm by any means. So what have I done? I've taken my English, I've taken the concept that I wrote in English, which is if n is divisible by these numbers, this or 3 or this, then not divisible, sorry. If it's not divisible by 2 and 3 and so and so, then n is prime. Otherwise, it is not prime. The other way of writing this is if n is divisible by 2 or 3 or 4 or any of these numbers till n minus 1, then, right, then n is not a prime. Then n is not a prime. Else it is a prime. Else it is a prime, right? So this is another way of writing the same thing in English. So what have I done? I've taken something that I've written in English and I've converted into simple code. So this code is often in computer science called as pseudo code, because this is actually not code itself in any programming language. This is not code. This is how the logic flows. But remember, here we have used all the key constructs. We have understood the concept. We have used the concept of a variable. We have used the concept of a loop, a for loop. We have used the concept of an if, right? So we have used conditions, we have used loops, and we have used the concept of a variable. And we've also used an operator here called the modulo operator, right? So the key thing is, first, given a problem, try to write it down in English, the way you understand it. Then convert it into some pseudo code. Try to write this in pseudo code. Again, this is for beginners. If you're an expert, you can write code directly. Then function, or what tool can I use to input a number in Python? So convert each of your lines of pseudo code into program now. Okay, so let me show you some very simple, crude program that I wrote here. Okay, look at this. What have I done? Num equals to input this. So this input function, this input is a function here, right? Helps me input a number and it will convert that into integer. So this line is exactly same as this line here. So what am I doing? I'm taking my pseudocode, converting into the programming language of my choice. Once I have this logic, I can convert into Python, I can convert into C, C++, any language of my choice. Okay, then what am I doing? I'm saying for I equals to range 2 comma num, which means from 2 up to from 2. So what does this range function do? Again, we discussed this in the course. And if you don't know, again, this is a good question. If you don't know what this range function does, or to be more important, if you don't know, so if you don't know how to write this iterator from 2 to n minus 1, let's assume you forgot the syntax or something like that. How do you figure this out? Okay, so let's just go to Google. I mean, that's the easiest way to do it. Okay, so let me go here. So Python, sorry, let me type it down here. So I'll simply say Python for loop 2 to n. Okay, let's say 2 to n minus 1. I'm just literally writing. If I just go here, okay, there are tons of tutorials here to help me. Okay, so immediately you'll see a function like this, right? Immediately, the very first Google search link shows you that if you write range 4 to 10, it gives you 4, 5, 6, 7, 8, 9. So all the numbers starting from 4 up to 10 minus 1. What did I do? I just Google searched the question that I had on my mind. I simply Google searched for it. And oftentimes you may not find the answer in the first search result itself. You might have to read through 3 or 4 search results when you Google search, or you might have to modify your Google search result, right? So very simply speaking, if you do not know how to do this, just Google search for it. For example, if I have to write code in, let's say, Ruby. For those of you who don't know, Ruby is a programming language. I don't know Ruby. But we can simply understand how a for loop works in Ruby by just doing the same Google search. For example, I'll tell you, I don't know Ruby, by the way. For loop Ruby. Okay. Okay, there is some tutorial here. Let's just go and see. By the way, to be honest, I don't know Ruby. Okay, not at all. Okay, this is while loop, right? Is there a for loop in, I'm just checking. Is there a for loop in Ruby? I don't know. I'm also still seeing Ruby while statement, Ruby while modifier, Ruby until, Ruby for statement. Okay, let's look here. Okay, so this seems to be the syntax in Ruby for I in 0 dot dot 5. Okay, so what does it do when I do this? When I do 0 up to 5, including 5, unlike Python. Okay, so if I were to actually write this code in Ruby, which I don't know at all, I can just look at this. What is it doing? It is saying for I in 0 dot dot 5. Right? Then immediately what will I try? I'll say for I in 2 dot dot n minus 1. I don't know if this will work in Ruby or not. I actually don't know. I don't know if this is right syntax also. But I'll try it. I'll experiment. It might fail. Then I'll again Google search and try to find the answer. Right? So if you have this statement and if you don't know how to write it in any programming language, just Google search for it. There are tons of resources online to help you. This is how I learned most programming languages. I actually read the very basics, get started, right? Just simply get started and get going, right? So, okay, so look at this. So if I don't know this range function, I'll just Google search for it and find that this range function works. Okay, just ignore this print statement. I'll come to it in a few minutes. Just ignore that for now. That's for debugging. Just ignore that. Then now what am I saying? How do I compute modulo operator? Now what is my next line? If n modulo I equals to 0, if I don't know how to compute modulo operator, next question, right? Again, just a Google search away. Again, it's simple Google search away. Okay, let me just change here. Python modulo operator. Sometimes a good example is example. Just type example, people will tell you. Okay, again, Stack Overflow is a phenomenal resource. If you just do this, people will give you hundreds of resources. Okay, see, it says 9% 2 is 1. Okay, it says percentage, the symbol percentage evaluates the remainder. Somebody told me the answer right there and then, right? So if you don't know anything, everything is mostly a Google search away, right? So the moment I realized that percentage is a modulo operator, I said, if this is true, then print not a prime and exit. If I don't know how to exit, a program, again a Google search away. Just Google search how to exit a program. How to exit a program. Python. Of course, you might have to re-edit this a little, but then you'll get this answer. And what have you done? It checks all of them. If this program doesn't exit, which means your number or n is not divisible by all the numbers between 2 and up to num minus 1, including num minus 1, because that's how range is defined, right? And hence you say it's a prime number. So what have I done? There are 3 steps to it. First, grasp the concept in English, try to write it in the simplest English sentence or paragraph constructs that you already know. You know that there is something called a for loop. You know that there is something called a variable. You know that there must be some modulo operator, some conditions. That's all. Just try to convert into this. Once you convert into this, translating that to code is trivial. And you can convert this to any programming language for that matter. Okay. So the key here is, the most important step is to get the logic right. This is the most important step. Once you got the logic right, being able to translate that to pseudocode is very important. Once you got into pseudocode, you can translate it to any language if you know the basics of that language. Even if you don't know the basics of the language, you can Google search for it and write decent code. Not the optimal code, but decent code. Okay. So very simple, nothing very fancy. Of course, I can execute this here and show you. This works, obviously. Let's say I type 5. Okay, so I'll come to these statements. I'll come to these statements and why these print statements are there. Okay, I'll come to that in a couple of minutes. Okay, back to our notes doc. Again, I'll share these notes for you. I'll share all the links that are here. But the key thing here is write the logic and convert it into a pseudo code using conditions, loops, functions, recursion. Break the problem into smaller components. Okay, then write your code. Of course, Google search can help you. There is a third very important thing. If your program is not working as expected, what do you do? So we have a section called debugging Python code in our course. But there's a much simpler thing. You can just literally print and see what's happening. For example, okay, let me show you this code here. Let me show you this code. So here, while this loop is running, I want to understand. So this print line is here, just for me to understand what's happening internally. Okay, me hypothesizing what is happening is different from what is actually happening internally, right? So what do I do here? I print num, I print I, and I print num modulo I. I print these three things so that I know exactly what is happening inside this loop, and I can verify what is happening in this loop. Is it exactly same as what I think it is? Okay, so for debugging, if you're not comfortable with using debuggers like Python debuggers, etc., simple print statements can help you. That's how I learned debugging, at least. Okay, so for example, let's look at this. Okay, so Python is prime. Suppose let's assume I enter a number like 19. Okay, let's assume I enter a number like, let's assume I enter a number like 19. So first what it does, it says my input number n is 19. Okay, I'm trying to divide it by 2. My remainder is 1. Okay, then 19, because look at the code here. That's important. Look at what I have in the code. What am I printing? I'm printing num I and num percentage I. Those are the three things that I'm printing, right? So if you look at the happening, I'm trying to print 19, which is my number, with 2 first. Remainder is 1. Because the remainder is 1, nothing happens, right? Because if the remainder was 0, it would have printed not a prime and come out of that loop. Then I check it with 3, with 4, so on and so forth, with 18. None of them, if you notice, none of them are 0. Because none of them are 0, it prints prime number. So just adding simple, sorry, let me, okay. So just adding simple print statements here can help you debug what is happening and understand what's happening internally. Okay. So very simple stuff, nothing very fancy here. Again, some of you may be bored that this is too simple an example. We'll go to the more complex examples, right? So this is the crux of it. So given any problem, these are the 3-4 steps that you can do to actually write simple programs. Again, now you might wonder, how do I become good with programming? There are no shortcuts here. You got to practice. You got to practice. Okay, so this is a very nice link where you have hundreds of programs, Python programs, that you can practice. There is another thing, which is read others' code, right? It's very good to read others' code and see how they implemented it. Okay, to learn good programming practices. But just reading others' code will not make you a good programmer. Just because you read Shakespeare doesn't mean that you can write as good a literature as Shakespeare, right? So you got to read others' code to be able to appreciate and learn good programming practices, but you can't escape writing your own code. Okay, you cannot. Let's be fully honest here. There is no escaping the fact that if you're not a good programmer, the only way to improve is to program. Okay, so let me show you. This is a very nice list of examples. Look at this. They start with the simplest of examples. Python program to add 2 numbers. That's where they start. Okay, then they keep increasing the complexity. Again, most computer science students during their undergraduate days would have written this in maybe C, C++, Python, Java, whatever it is, right? This is how many people learn programming in the real world. Okay, then Python program for factorial of a number. Of course, if you click on any one of them, you'll get code. Okay, so for example, if I click on this, I'll get some code in Python. Okay, some explanation and some simple Python. Okay, some simple code. This is like a recursive code. Okay, there is also an iterative code and all of that stuff. Okay, the key here is look at the problem. If you look at the solution, you're not learning much. Let me tell you that. First, look at the problem. Try to write the code yourself. Try to write the code. Try to write the code yourself. Struggle through it. That struggle is mandatory if you want to become a good programmer. Okay, struggle through it. You cannot escape this fact in the long run if you want to become a good programmer. Right? It is a skill. It is just like swimming, or it's like running marathons. The more you do, the better you become. Right? It's like learning bicycling, right? When you learn to cycle, right? Exactly similar stuff. The more you practice, the better you become. So these programs are very, very simple programs, and you can write your own code. Once you write your own code, struggle through it, use print statements to understand what is happening, and then read the code that they have provided also, because that will give you additional data points, right? So there is no escaping the fact of actually programming and struggling through it. That's why even in our course, we want students to do assignments, because that's the only way they learn about the real world and pick up these skills, not just in programming. Okay, I'll come to optimized code and all of that. Let's take a second simple problem. Okay, suppose imagine I have a list of numbers. Let's say 1, 2, 1, 4, 6, 8. Suppose I have a list of numbers. I want to compute the frequency of each number. What is a frequency? Frequency basically means the number of times each number or each element occurs in your list, right? That's what it is. Suppose imagine if you're given a list like this. Okay, imagine you're given, so this is problem 2. Okay, so imagine you're given a list. Okay, you're given a list 1 1 1 2 3 2 3. Okay, 4 4 4. Okay, now I want to count how many ones are there, how many twos are there, how many threes are there, and how many fours are there. That's what is called the frequency count, or finding the frequency of occurrence of each of these elements. So how many ones are there? So to do it, how do I do it manually? I go through each element. And I literally count how many times one exists, right? The moment you see that I'm repeating something many times, it should remind you of for loops. Obviously, right? It should remind you of for loops, logically speaking. So here I say 1 exists 3 times, 2 exists 2 times, 3 exists 2 times, 4 exists 3 times. How did I do that? I basically counted. So basically I created a new array right now. We've learned about arrays a lot. Okay, so imagine I have 4 elements, 1 2 3 4. Whenever I see 1, let's assume all of them are initialized to 0. The moment I see 1, what will I do? I'll increment this, or I'll increase this by 1. Right? The moment I see 1, I'll increment this by 1. So again, I see 1. So what should I do? I should increase this again by 1. Because I've seen 1 2 times. Again, I see 1. What should I do? I should increase this by 1. Now I see a 2. So this should increase by 1. Because I've seen 2 one more time. Now I see 3. As soon as I see 3, what should happen? I should now increment this. Now again, I see 2, which means this should get incremented. Now again, I see 3. So this should get incremented. I see 4 3 times. So first it will become 1, then it will become 2, then it will become 3 finally. Now I can say, yes, 1 occurs 3 times, 2 occurs 4 times, 3 occurs 2 times, 4 again occurs 3 times. Right? Very simple logic. So of course, you can write your own code. So first thing, what did we do? We tried to solve the problem, right, using our own intuition. First, we try to understand the intuition or the code using arrays or hash maps, right? If you know hash maps, or if you know dict, as it is called in Python, or dictionaries, right? They're also called as hash maps in other languages. Again, we discussed this extensively in the course, right? And of course, you have to know for loops, right? You should know how to increment a value, right? Using these logics, using this, you can convert the logic that we just discussed right now into pseudocode. You can convert this whole thing into pseudocode. Once you convert everything into pseudocode, the third step is translating into Python. This is the third step, right? Of course, this program is slightly trickier than the previous one, but both of them are simple loops. But there is another way to solve this problem. This is one way. This is one way. By the way, in programming, there is no single way to solve a problem. If you ask two people to write the program, very likely, if they have not cheated, there's a very high likelihood that they both will write very different programs, right? So let's see how to actually count frequencies. Suppose I want to figure it out. Of course, I've thought through this logic, all of that stuff. Okay, very good. Is there another way? It's always good to learn multiple ways to solve a problem because that improves your knowledge base. Okay, so I'll say frequency. I'll say how to compute frequency of items in Python. That's all. How to count the frequency of elements in a list. Stack Overflow. Very first question. Okay, so somebody asked this question that I have. Very good question. Exactly what we want, right? Google is terrific with the search results. I have these numbers. I want to count how many times each of these numbers occur. Okay, so as soon as you go, people have written like this is a slightly more complex way of doing it. Just don't read only one answer. Read multiple answers. Oh, here is a very simple line, right? If you notice this line is very simple. There is this thing, there is this module called collections or a library called collections, and you can create a counter object. And if you say print counter, it will literally print how many times each of these is occurring. So what has happened is there is an existing function called counter, right? There is an existing function called counter in the collections module, which actually does that for us. But let's learn more about this. Instead of just using the same thing, let's actually learn more. It's very, very important. The moment you realize this, you should read the function definition or the function reference. Counter, let's say in collections Python reference. Okay. Okay. So I have collections and I have counters. I'm trying to do this almost live here with you. Okay. So I have a counter here. Okay. So let's go to counter. So what does the counter do? I hope this is the same collections.counter. Okay. So a counter is a dict subclass for counting hash table objects. It is an unordered collection where elements are stored as dictionary keys, blah, 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 blah. It's always good to see code. Trust me. Okay. There is nothing better than actually, of course, because when you read Python reference, this is the Python original official documentation. So they try to be very, very accurate, very, very rigorous with every statement that they make. So the best thing, of course, if you can understand this, that's great. But if you cannot understand this, which could happen to many people, because you may not know what is a subclass, you may not know what is a hash table object, right? There are many terms that you may not know. So the best thing forward then is just say collections counter, right? Examples. Again, what are we doing? We're just saying counter.values, right? So the moment you say this, okay, on HackerRank, there are some examples here. Okay, just go through as many examples as possible. Okay, somebody has given some nice example. Okay. Okay, here is a problem. Okay, my list, blah, blah, blah. And again, when you go through examples like this, things will become much more clearer for you. Here, what is this person doing? He's basically creating a list and their print counter of this list. So it's basically saying 2 occurs 4 times, 3 occurs 4 times, etc., etc., etc. 5 occurs 1 times, etc. So that's what it is literally doing, right? So by just reading through examples, if function reference gets hard for you, the easiest way would be to read multiple examples, right? So of course, it's good if you can implement this with your own logic. Certainly, this is one way of doing it. The alternative way, there are many ways of doing it, by the way. The alternative way is to use collections.counter. And how did I know this? I just Google searched for it. And I just didn't just Google search for it and got the code. I tried to learn about how this counter works either by reading the function reference, and if sometimes reading the function reference is hard, then it's very easy to actually go through many examples to understand what's happening. Because this, of course, function reference is certainly a more rigorous way of learning it. But if you don't understand it for some reason because you're still a newbie and you're still learning the basics, this is one of the best ways. Okay. So the key here is, again, write the logic, translate that into code. Obviously, write your debug statements, write your debug print statements to understand what's happening so that you get to know what's happening, literally. Right? Again, there are no shortcuts here. It's all about practice. Again, I'll provide the link to this whole document at the end of this session as one of the comments for the video. So don't worry about taking notes. I'll provide this whole document to you. Right? Very important to read others' code to learn good programming practices. You can't escape that. You can't escape writing your own code. There's a very key thing that some of you who are actually good programmers might be thinking. Writing code effectively and writing optimized code, right, are two different things. Here, what we discussed till now is writing some code, writing working code, writing some code that works. Okay, writing some code that works, not necessarily the most optimized code. So writing optimized code would require you to know two things. Again, in the course itself, we discuss a lot of data structures and algorithms, right? We discuss about hash tables, okay, in the context of dictionaries. We discuss about advanced data structures like KD trees, right? When we learn, I think when we learn K nearest neighbor, we learn advanced data structures like KD trees. When we learn decision trees, right? We learn about a data structure called a tree, right? We also learn about various algorithms, like how to search for an item, right? How to search for nearest neighbors using KD tree, right? So in machine learning, also, we use a lot of data structures and algorithms. Like we learn a lot of machine learning algorithms and optimization algorithms like stochastic gradient descent, etc. Right? So algorithms is a huge subject. There are also classical data structures and algorithms that computer science students learn of. So this will certainly help you become a better programmer. Okay, if you have time, if you're willing to put in the efforts, learning data science and algorithms, learning data structures and algorithms is a very good investment of your time to become a good programmer, to become a actually very good programmer. If you want to become a very good programmer in the long run, it is good if you can learn data structures and algorithms. And similarly, to write optimized code, you need to learn the language in detail. For example, here, I don't know Ruby, so I can't write optimized code because I don't know how the language works internally. I can write very efficient C, C++, even Java and Python code because I've spent years writing code in C, C++, Java, and Python and understand lots of internal details of these languages, right? I know how memory is allocated in C, how memory is deallocated in C, how references work in Python. All these program-specific details I understand very well. So to write optimized code, you have to learn both the programming language and become good at data structures and algorithms. But to write working code, not necessarily optimized code, you don't have to be an expert in all of them. Certainly knowing them is beneficial. Let's not kid ourselves with that. Some time there before we go to the second part. Okay, I'm here and let's go to the comment section. Okay. Okay, let's go through some important ones. Okay. I'll just scroll a little so that I can answer more. Okay, so of course, somebody was suggesting that we can check if a number is even. We don't have to do it. Obviously, there are many optimized ways of checking if a number is prime or not. I'm not denying that. What we wrote is a very simple stuff. Okay, very simple algorithm. Of course, if you can optimize it using some properties of prime numbers, that's certainly beneficial. But let's get the basic code first, and then let's do the optimized code later. Okay. So while I'm going here, Some books for data structures and algorithms. There is one book which I would call it literally the best book that I've ever read in my life. I still have that book right in front of me on my bookshelf. This is called Introduction to Algorithms by Carmen, Leeserson, Rivest, and Stein. It popularly called as CLRS. I think this is the best book I've ever read for data structures and algorithms in my life. I bought this book in 2004 in my BTech second year, first semester. And the book is still with me. I still refer to this book whenever I get stuck for some data structures algorithms. I don't know how many times I've written on it. I've highlighted it. It's like a terrific book. It's if you want to read a book for data structures algorithms, especially, of course, this is not like an expert level book, but this book has helped me over the last 15, 16 years, whether I have been working at top-notch companies or as a student, right? So that's the best book if you want to pick one. Somebody's asking why not R, why more emphasis on Python? Very simple. Again, I've explained this multiple times on different videos also. See, Python is a more general purpose programming language, right? R, on the other hand, is specific for statistics. So certainly there are more libraries available for Python. So if you're learning a language, why not learn a general purpose language? You can build a web browser in Python. You can build a web scraper in Python. You can build literally Google search on using Python today, right? You can write world-class code using Python and deploy it in production, large-scale code. Of course, R is catching up. R is very strong with statistics, not so strong with other aspects. So if you're picking up a language, why not Python? That's a counter argument, because Python has very good libraries for everything from basic statistics, plotting tools to deep learning. Whole of machine learning and Python, right? Again, don't get stuck on a language. That doesn't mean R is not a good language. I've used R personally a few times. Like I've started learning from Fox Pro, C, C++, Java, Python, .NET. I've tried a little bit of Perl in between. I write a lot of shell scripts. I've written a little bit of C# also and ASP.NET a couple of times. I've written a lot of PHP code for a while. For the last few years, I've moved to Python, and Python has become my primary programming language. But if there is some library that is not available in Python but available in R, I just pick it up. What is there in picking up a programming language? It's just a Google search away. Of course, becoming an expert in a programming language will take time. But just writing functional code, if you got the logic right, writing functional code is very simple. It's just a Google search away. We just saw Ruby a while ago, right? So, okay, so let's go ahead. Let's go up a little. Somebody was asking about the previous live session. I think we sent on Slack the Google Doc to all students. So if you're a registered student, if you're not on Slack, please join our Slack official channels, and all the data we share constantly on Slack. It's a very, very active group on our official Slack. So we already shared, I think I shared the Google Doc 10 minutes after the live session. So it's available for everyone to check out. Okay. There's some general questions about applied AI course. I will not go into them. If you have any questions about general questions about machine learning or applied AI course, please call us on the phone numbers on our website. I want to keep this session limited to how to write programs efficiently, how to build a scraper. I don't want to deviate into applied AI course content or machine learning and things like that. Okay, please, sorry for that. Okay. Okay, any other question here? How important is to make ML models using libraries? That's what most people do. Anyway, I don't see anything exciting anymore. Yeah, people have been asking me about applications of machine learning in various areas. We'll do probably a different live session. I want to confine this live session to writing good programs, effective programs, and to build a simple web scraper, because a few students have asked us about web scrapers. And okay, before we go into web scraper, just a quick water break for me. I think we're almost an hour into it. So next 1 hour, I'll try to spend for web scrapers. Before I go into web scraper, there's a very interesting thing I wanted to tell you. Just give me a sec. Okay, so you might wonder what is web scraping in the first place. Okay, so I'll explain you that a little before we dive into it. So again, why is web scraping important? We'll come to that. So a very interesting way to actually build your own portfolio of projects or to do your own case studies in machine learning. A very interesting way. What a lot of people do is this: you get data from the internet. Like for example, you get data from Kaggle.com or Wikipedia or other data sources. You get the data, you build some machine learning models on top of it, you do some data analysis, machine learning, deep learning models, you try out multiple models, you explain the business context, you explain how to deploy the model, you do all of that. That's great. That's certainly a very good portfolio project or a good project for you to showcase your skills in machine learning and data science. There is one piece which can make your portfolio terrific, okay, actually brilliant, which is obtaining your own data. Lot of times people actually obtain data from Kaggle or from other sources where people already collected the data. Again, by the way, we have done this a lot in our course case studies also. There is one very interesting course case study about Amazon apparel recommendations, wherein we got the data about, I think, a few 100,000 apparel products on Amazon.com. We actually got the data from Amazon website, and built models on top of it, right? This data was not given to us on a plate. We didn't download it from anywhere. We wrote scripts to actually obtain this data. Of course, I'll tell you how to obtain the data, how we wrote it, all of that in a little while. But just because we have done that, now imagine you have two projects or two case studies that you've done. One case study where somebody gave you the data, you did all of the machine learning pieces very well. Okay, you wrote a brilliant blog, you have a nice GitHub profile, everything. That's one project. Let's call it P1. Suppose there's a second project where you did all of the machine learning part, data analysis, blog, you did all of that very well, plots, everything. But instead of getting the data from Kaggle, like in your case one, you actually wrote scripts to get your own data. That is case two. So if you present case two as a case study that you have done, your chances of showcasing your skills, not just in machine learning, but also programming, are large, because now people will say, oh, this person is not limited to just data set, somebody giving a data set. This person is going out there, grabbing the data that he wants in a legally compliant manner. Of course, I'll come to legal compliance and all in a little while. So he's obtaining the data, he's writing code to obtain the data himself and building models on top of it. That showcases your skills both as a programmer, as a go-getter, because data was not given to you. You wanted to solve a problem, you went and got the data. That shows you in a very interesting light of being somebody who gets the data that he or she needs. Very interesting. So to do a great machine learning project, in addition to doing all of the machine learning components, if you can somehow get the data that you need yourself, that is like bonus points. Now the obvious question here is, how do I get the data? Okay, so I hope I convinced you that getting your own data, if there are instances where you can get your own data, that adds value. The immediate question is, how do you get your own data? Obviously, if the data is owned by a company, let's assume the company doesn't want to share the data, you should not touch it, because there will be legal repercussions for it. For example, I'll give you an example. Okay, so for example, Amazon is very reluctant to share their customer review data, because customer review data of Amazon is super critical to Amazon's business. It is something that only Amazon has. A lot of customers come to Amazon because of their customer data. So Amazon will stop you if you try to grab their data from their websites or scrape their data. The word there is scrape. Scrape basically means you write some code to visit a web page. Okay, you write some code to visit a web page. Just get the whole content on the web page. That's what is called scraping. Okay. Within scraping, you have to be very, very careful not to violate the policies of the website that you're scraping. You have to be very, very careful not to avoid it, because there will be legal repercussions. For example, if I write a script to simply scrape Amazon's product reviews, Amazon has a terrific system which detects that I'm trying to do this, and it will block me. Okay. And if this case is severe, there have been instances where Amazon has taken legal cases on perpetrators who have already been warned, because Amazon doesn't want to give you that data. There are other pieces of data that Amazon is willing to share, right? So Amazon is willing to share the product name, sometimes even the product price, sometimes, not always, or the product availability. So there are some pieces of information that Amazon is willing to share. There are others which Amazon doesn't want you to have. Of course, Amazon might share some of this information with some companies like Google, for example. So for example, how does Google work? Think about it, right? Google literally crawls the internet, which means it goes to almost every web page on the internet, right? Scrapes the page, obtains all the information in the page and stores it on their servers, so that when you search for it, it's able to bring that information to your disposal. Okay. So what Google is doing is basically an internet scale web scraper. But companies want to be on Google. Amazon allows Google to scrape their information comfortably. That's because Amazon wants their products to be searchable through Google, right? On the other hand, Amazon doesn't want their competitors to be able to crawl and to be able to scrape the information on their web pages, right? So to be honest with you, scraping has legal repercussions. So you have to be very careful before you scrape a web page. Please read the policies and terms and conditions of the website and oblige by them. Okay. I'm being very, very serious here. Okay. Please don't take it lightly, because I know a few companies which got shut down because of it, and few individuals who are behind bars because of it. Okay. I know Amazon itself taking legal actions against some individuals and companies for things like this. Having said that, the second best way to obtain data is through something called as APIs. We have discussed this in one of our previous sessions. So the way an API works is like this. Okay. Okay. Let me just explain you here with hands, right? Suppose this is Amazon, right? This is Amazon servers. Amazon servers say you can call a function that is sitting on a server on Amazon. Okay. You just call this function and say, I want to see the top 100 search results when I search for, let's say, a kurta or a t-shirt. Let's say my search is t-shirt for men. I can just call Amazon search API. Amazon provides a search API, by the way. I can just call this API. This API, which is residing on a server, gives me the top 100 search results. Amazon literally lets you do this much more efficiently. So if there is an API available to obtain data legally, which is provided by the company or the website, please use that. That should be the best one. So for example, for our Amazon fine food reviews, no, for our Amazon, sorry, not fine food, fashion discovery engine, we have a case study called Amazon fashion discovery engine. What we did was we did the legally compliant way. We used Amazon's product search API. We called the product search API and said we want to see the top products for t-shirts. Of course, we called this API many times. Amazon lets you call this API only a few times per second or few times per minute. We called it accordingly. Amazon gave us the data. It took us like a couple of weeks to obtain all the data that we needed, but we did it in a legally compliant manner, right? Using Amazon's provided APIs. And nobody complains when you do that. Okay. And actually obtaining the data using Amazon's own API is like 10 lines of Python code, literally 10 lines of Python code. That's all there is. Okay. So if there are APIs, please use them. If there are no APIs, and if you still want to scrape, read the terms and conditions and the policies of the company. Assuming that you are on the right side of the legal system, now let's see how to actually build a simple web scraper. Here, I'll introduce you to new modules and new libraries. There is no fear in this. This is a straightforward thing. Okay. So let me take myself off the screen. Okay. So back to my notes. Okay. Again, here we are not building an internet scale web scraper. We are building a simple web scraper. I want to make that clear. I'll show you two types of web scrapers, right? The first one is a very simple web scraper. Of course, the web scrapers that Google builds are like, again, there are companies which have hundreds of software engineers. They're like large companies like, let's say, Google, right? Bing is owned by Microsoft. and other large companies which are there in the search space, like Yandex, which is a Russian website, right? Similarly, the large search engines, right? They have hundreds of engineers, world-class software engineers working on their web scrapers. Okay, and these things actually scrape a large part of the internet. And lot of e-commerce players, right? Lot of e-commerce and even regular brick and mortar store companies like Walmart, right? Lot of these companies, lot of retail companies, they're called as retail companies, also scrape their competitors' websites to understand the prices of products so that they can price accordingly, right? Of course, they have to do it within a legally compliant manner. But I know that a lot of e-commerce companies and regular retail companies like Walmart, Target, these are all large retailers in the US. They all scrape each other's websites within a legally compliant manner to obtain the prices, so that if Walmart wants to change the price because Target has some price or Amazon has some price, makes some complete sense for Walmart to scrape these pages in a legally compliant manner and adjust their prices accordingly to be competitive with both e-commerce players and other offline retailers. And for many of these companies, there are hundreds of software engineers who might be working on projects like these, right? So I'm not competing. I'm not saying you'll be able to build a world-class web scraper. What we'll see is a very basic web scraper, and we will build on top of what we learned in the first part, which is how to code effectively, right? So we understood what is a web scraper. Okay, so let me just draw a simple diagram here. So I just gave you a quick overview of what a web scraper is. A web scraper is basically a piece of software that you write to be able to get information or get critical data that you want from a web page. Okay, get data or obtain data from a web page in a policy compliant manner. Okay, the policy compliant part is very, very important, trust me. Okay, so the second thing is use APIs if the website provides you one. I'll show you an API actually. I just want to show it to you so that you're clear about it. So for example, again, let's Google search API. Okay, Python. Okay, somebody's already filling it for me. Okay, the moment I type this, okay, wow, I have some code here. There is actually a module. Okay, this is a simple Python wrapper for Amazon product advertising API. Let's look at some code. I can install this package, okay, by just saying pip install this. Look at some code here. Okay, let's look at some code here. What does it say? I can create from Amazon.api, import Amazon API. And of course, I need some key that Amazon provides me. Of course, all the documentation can be read here. And I can say, okay, I can look up for a product. This is the product ID. The moment I look up for it, it says what is the product name, what is the product price, all that information it gives me, right? So very simple. So there is already somebody has taken the time to write functions on top of Amazon's product advertising API and make it available for you, right? So just a couple of Google searches away, you'll get some simple code. Read the function documentation, read more example code, and just build a simple stuff, right? Actually, we did it ourselves for the Amazon fashion discovery engine case study, right? So if you have APIs, many large companies would have APIs, right? So try to use APIs if the website or the company provides you one. Okay. Next, let's go to a simple static system. So what is a static system here? So websites or web pages, those of you who don't know how internet works or how web pages work, or some people who don't know what is JavaScript, what is HTML, I'll not be able to go into full depth because that's like a 50-60 hour long detailed course in itself. So I'll give you pointers and I'll give you high level overview here, okay, with some simple code to follow. Basically, there are two types of web pages. Most web pages today are written using HTML. Okay, it's called hypertext markup language. Okay, so of course, so a web page can be a static web page. A static web page is something where the content is static, it doesn't change. A dynamic web page, so there is also called as, so static web pages are built using HTML. There is something called as dynamic web pages. Okay, dynamic web pages use HTML and other tools like JavaScript. Okay, of course they would have many other tools like Ajax, etc., 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 right? So in a dynamic web page, right, The content in the web page, is not static. It changes dynamically. And the moment, okay, I'll tell you more details when I come to JavaScript and things like that. Okay. So for now, let's build a very simple HTML page. If I have a simple HTML page that is static, so what happens is when your web page loads, right, there is some HTML code which tells you how the web page should look like. There is some JavaScript code. Okay, JavaScript has functions and everything like that, right? You can execute this function and fill in some details here, right? So when you actually pull, so for example, suppose this is my web server. Okay, I'm giving you very high level overview here. Please bear with me. Suppose this is my web server. Okay, this is my web server on which my whole web page is stored. Okay, this is my browser. Let's assume this is my browser. The moment I ask my browser to fetch a web page, what does it do? It brings all the it brings in all the HTML and JavaScript needed, and it executes the JavaScript on my browser, okay, to render or to display the whole page here. So as soon as the web server sends me both the HTML, JavaScript, and other pieces of information like images, videos, etc., right? The JavaScript actually runs in my web browser, right? The JavaScript runs in my web browser to be able to fill in some functionality or some information and create the final web page. So if a web page does not have JavaScript, right? If a web page does not have JavaScript, it is surely a static web page, which means I can just pull the HTML and everything is there. Okay, first things first. Okay. Okay, the way, how should I go? Okay, let's open this. This is a nice blog, okay, from Codecamp. Okay, this is how to scrape websites with Python and Beautifulsoup. Okay, those of you who don't know what Beautifulsoup is, Beautifulsoup is one of the best libraries. It's probably one of the best libraries to scrape any web page. This is used extensively, not just by novices. It is used even by the largest companies in the world, right? Beautifulsoup is basically like a library, right? It's basically a library, or you can think of it as a module, whatever you want to call it, right? It has a bunch of classes and functions which enable you to scrape web pages very easily instead of you writing code from scratch, right? So that's what Beautifulsoup is, a new library that I'll introduce you to. I'll give you a basic introduction so that you can follow up after that. Okay, let's take a simple example. This blog is very good. I'll provide a link to this also. First things first, you have to install Beautifulsoup. Without that, you can't do much. Okay, simple. Pip install Beautifulsoup. Or if you're using Python 3, pip 3 install. Okay, so let's understand the basic of what a HTML page looks like. Okay, so if you have any page, right, let's take this page. Okay, if I right click on it, if I say view page source, okay, what I get now is the whole HTML page. Okay, you can go to any page on the internet using your browser, just right click and say view source. So it says this document is HTML type, and it gives you this whole thing is your HTML code, and there are some scripts in between, okay, JavaScript or whatever script it is. But this is what, literally, this is what your browser gets. All of this is what your browser gets from the web server. This is what the web server sends to the browser. What the browser does now is browser takes all of this code, executes this code. Okay, sorry. So the browser basically takes this code, executes all the JavaScript and everything that is there to show you this final page. This is the final page that you see. This is called the rendered page. This is the actual source code, the HTML and JavaScript source code behind this, right? So if you have a very simple web page, let's look at this. Okay, very simple web page. This is the structure of a very simple web page. It says the document type is HTML because HTML is the language or the hypertext markup language that we use to represent web pages like this. Okay, so look at this. This is called HTML tags. These are called tags. Okay, again, this is a vast ocean. I'm not going into too much depth. I'm giving you a very introductory video here. Okay, this HTML. So everything in between these two is what is there within your whole stuff, whole HTML page. This section is called the head. This section is called the body of the page. Okay, so let me show you a simple example. Imagine if I actually store this whole thing. So imagine if I actually store this whole thing. Let's actually save this as test.html. Okay, this is my HTML page. Now, if I go to my browser and if I say file, where is this file? Open file. Okay, I go to my home page. Sorry, I go to my home folder. I say test.html. This is what it looks like. So this code that we had, remember this code that we had, this code that we had in test.html created, it literally created this whole web page here. Look at this. I've stored it in my home folder, test.html. That's all there is, right? So what is happening here is this page, sorry. I just hit my mic, sorry. Okay, so this is how a web page, a simplest web page is represented. So what does it have? It has the HTML tags, what is to be there in the head of the page, what is to be there in the body of the page. In the body of the page, it says there are two pieces. There is a header. H1 basically means a header. Okay, it wants a header, which is first scraping, and it wants a paragraph, which is hello world. If you want to learn more about HTML, there is a very good source called W3 Schools. Okay, I'll provide this link also. W3 Schools HTML. Okay, this is a very nice set of brilliant tutorials if you want to learn HTML. Let me add it to here. Okay, I'll add a link here so that I can share this doc with you and I don't forget it. This will tell you everything about what HTML is, what each of these tags mean and things like that, right? Just in the interest of time, I'm not going too deep into how HTML works and all of that. But any web page that you have is literally written in HTML and JavaScript, right? So having said that, of course, if you want to learn, there's a lot to learn here. I'm skipping all of that. Now to scrape, again, this is a very nice thing. Mostly what I've already told you, right? Please check with terms and conditions. And if there is an API, use it. Do not request data from a website too aggressively. Don't just request one page after other page because it could break the website. Please don't do that. Okay. Again, the third thing is the layout of the website may change from time to time. So you need to be very careful. Okay. I'll show you some examples, right? So here in this blog, I'm just following the example in this blog. They take you to this page. This is a page on Bloomberg. Okay, Bloomberg is one of the largest finance companies in the world, providing market information and stock market data. Okay, so on Bloomberg.com, I went and saw the price value of S&P 500. S&P 500, for those of you who don't know, is basically a stock aggregate of the top stocks in the US, top major 500 stocks. Okay, sorry. So suppose if I want to fetch this information from here. If I want to fetch this information from here, how do I fetch this? Basically, first, what are the steps? Let's write down the steps, right? What are the steps that I need to follow to scrape a page? Okay, logical steps. First, you have to obtain the page. You have to obtain the web page first. Obviously, without obtaining the web page, there is nothing for you to scrape. First, you have to obtain the web page. Once you obtain the web page, let's assume I obtained this web page. By the way, if I just right click on it, and say, sorry, if I right click on this, what is okay? What I get is the whole HTML page. This is the whole HTML page behind, of course, it's a huge page. Lots of information here, almost 800 lines of HTML page. And when you obtain a page, right, when you obtain a web page, what you get here is the source. What you obtain here is the source of the page, like the HTML and JavaScript part, right? It is the HTML and JavaScript part. Now, once you obtain the web page, the second thing is you have to pinpoint the information that you want, the data. You have to pinpoint the data or the information you want. You, of course, makes a lot of sense, right? You want this data. So for example, if I want to scrape the price of this stock, okay, if I want to scrape the price of this stock, let's say, okay, then it makes complete sense for me, right? It makes complete sense for me that I don't care about everything else, right? I care only about this part, the 2,792.67 US dollars, because this is the value of the S&P 500 index. You don't care about there'll be 100 or 1,000 things around it. This is the key information that I want to scrape and obtain, right? Let's assume. So you have to pinpoint to that. And then you understand the structure. Then you understand the structure of the HTML page, of the HTML or JavaScript source, right? Because see, again, by the way, once you understand the structure, because look at this 2792. Let's look at this, right? Let's look at the source here, 2792. Let's just control F here, 2792. 2792. Wow, this 2792 point, what is the number here? Exact number, 0.67. There are lots of 2792s. 0.67. Wow, this data is there in so many places. Okay. Okay, this data is there in so many places. Okay. Now how do I find where this exact data is? Okay, so suppose if I want this, right? There is this thing called as inspect, right? See, this is when I view source, there is so much of other information that I'm not able to understand where the head is, where the tail is, right? So what I can do here is I can right click and press inspect. Again, by the way, I'm on Chrome. Different browsers behave differently. Okay, the moment I say right click inspect, it says this information 2792.67. Look at this. What it says is very interesting. What it says here is this information is stored in my HTML file under something called as class equal to price text underscore some number. So if I can directly go to this place, because what I have is basically my HTML file. If I can directly go to this place and obtain this information, that's great, isn't it? What is one way to do it? I can use grep. Remember, there is grep in Python. Grep basically helps me to search for strings in Python, right? So what I can do is I can use, again, we discussed this in the course. If you don't know what is grep in Python, it's just a Google search away. Okay, you can search for this string called price text. Wherever the string price text exists, just right after that, look at this, right after this, wherever the string price text occurs with some number here, we don't know what that number is. Right after that, this information is present. So I can grep for price text, right? And move a few steps away, in code, and obtain this information and say, oh, I got the value that I want. Isn't it? Right? Very simple. That's one way of doing it. But the problem is grep. So you understood the structure of the JavaScript, and using the structure, you go to the position, or you go to the part of the file, of the source file. You go to the part of the source file where your information resides, where the data that you want is present, where the data you want is present, right? So for example, in this case, we realized that this is the data that we want to scrape, and this is present where, at this place. Whenever you see class equals to price text underscore something, right after that, I see my price information. So you pinpoint, you understand the structure of the HTML code, and you say, I know where to go to get the information that I want. Then as soon as you get it, you basically cut out, or you basically cut the data piece that you want. You basically cut the data that you want from the web page and store it. Done. That's all there is. That's all there is to web scraping. But here is a problem. Of course, companies don't want you to just scrape their websites left and right. They will put in a lot of hurdles to avoid you from scraping. Okay, like Bloomberg, one of the key informations that they have is the stock price, because they maintain a huge repository of stock prices over many years and decades, actually, right? If you just go to their website and scrape regularly all the prices, they're losing key information that they have, that they actually sell to their clients, right? That's why they do lots of, again, websites for any critical information that they don't want to share with you, they will try to stop you. Of course, again, grep is one way of doing it, but Beautifulsoup is a toolkit, or is a module that is designed specifically This was, again, let me show you this, right? When this guy was writing his blog, this information, the S&P index then was 2022, right? This information, look at the class name. The class name was price and not price text. So this web page, Bloomberg, changed the name of the fields, changed the website itself dramatically, changed the names of all of these so that people can't scrape them, right? We saw just now, right, that they've actually literally changed so many. Like we saw price text underscore some number, right? We saw price text underscore some number. Here they've changed the whole website and the whole structure here, right? So this code that is there on this web page assumes, right, this code that is there on this web page assumes that everything is in this format. Okay, so what it says is this. It says that this information price is available, right? First there is a division. So div basically means a division. There is a division called basic quote. Within the division there is another subdivision called as price container up, right? Within that there is a subdivision called as price. That is the architecture, right? Again, if you notice, a HTML is like a nested loop. We've seen nested loops, right? A loop within a loop within a loop type of structure. HTML is also a nested structure, not a loop structure, but a nested structure. Where, if you notice, okay, let me just show it to you. Okay, let me just show it to you. So first, look at how it looks like. Within this div, okay, there is a main. Within this, there is another div. Within this other div, some header, some div, some div. So there is this nested structure in all of HTML pages. Okay, again, if you really want to be a good web scraper, you got to learn the basics of JavaScript and HTML. W3 Schools is a good starting point. Okay, so now how do you do it? Now how do you grab the price, assuming that this is the structure and the structure hasn't changed? So when you go to this class price, right, there is this thing called name, class name, which tells you about the stock name also. So the class equals to name tells you the name of the stock that you're pulling information for. Class equals to price. Within this structure, within this complex nested structure, class equals to price helps you get the price. Now we want to get all of this information. Of course, writing greps is one way, but Beautifulsoup is a faster way. Okay, so you import the libraries. Oh, this library is very interesting. What this library urllib2 does is it helps you solve the first part, obtain a web page. So urllib2 basically helps you. This is a library which helps you obtain a web page. Again, you could find that from Google searching. Okay, now it says from BS4 import Beautifulsoup. Of course, you need Beautifulsoup to parse the whole thing, right? Again, there is this keyword called as DOM tree. I want to explain that. So your whole, okay, let me zoom this in. Okay, your whole HTML page is stored using something called as a document object model, where you have the whole document. Within the document, look at this nested structure or a tree-like structure. This is called a DOM tree, okay, or a DOM nested structure. What happens is most HTML documents are arranged like this, where this is your HTML document. Within this, there will be some head. In the head, there will be some title. In the body, there will be some header, some element, some link, all of that stuff. So you can think of this like a tree data structure, right? So you can think of, so this is called the DOM tree of a HTML page. Okay, or you can think of it as like a nested tree, or you can think of them like a nested structure. Okay, so whenever you see the word DOM in web scrapers, just understand that it is the way that the whole HTML page is stored. It's called the document object model. Okay. I'm saying this is the page that I want to scrape. This is the exact page that I want to scrape. So first thing, what do? I basically say urllib2.url open. So what does it do? It asks the website to return this page. And this page, so when it returns, what it returns to you is the source. It returns you the source of the page. When you right click and see view source, that's what is now stored in page, right? Now, once you have the whole HTML thing, once you have the whole HTML file, two things you can do. One thing, you can use grep on top of this, of course, but getting grep to work will be very, very cumbersome. The second option is to use Beautifulsoup because it internally uses grep extensively. right? So let's go step by step. First thing that I'll do here is I'll create a Beautifulsoup variable. Okay, think of this as a variable, and I'm saying I want a HTML parser because I want to parse, right, a HTML page. Very simple. Next, what I'm saying is here is very good. Okay, this is actually very good. Now what I'm saying here is I want this. So I want to find a header h1 which has this attributes called class equals to name. We saw this earlier, right? With class equals to name, I'll get the whole name box. Okay. So what is the name box here? Let me just show it to you visually. So here, this is the name box. This will tell me what is the name of the stock. This tells me the price. And we saw while going through this that h1 class equals to name gives me the name of the stock symbol that I'm pulling data for, and class equals to price is giving me the information of the actual price itself. So in Beautifulsoup, what I'm doing here is I'm saying, see, Beautifulsoup is very simple this way. It's saying I want to find a h1 or a header one, right, which has this attribute called class equal to name, or I want to find this attribute called class whose value is name, right? As soon as I get that, I get something called as I store this result in a name box. So name box stores only the sub DOM. Imagine this is my whole DOM. As soon as I get this, only the sub part that corresponds to this search, because it's using a find, right? Only the sub part corresponding to it is returned as part of my Beautifulsoup. So Beautifulsoup has parsed all of this and returned me exactly wherever this condition is met. Now I'll use .strip. Strip, basically what does it do in Python? It removes all the starting and trailing stuff. Then I say print name. I literally will get the name of the stock now. Very simple, right? Similarly, I can get the price also. What will I do? I'll say now soup.find, find me a div, right, which has this attribute of class whose value is price, right? So as soon as I got this, I'll say my price is price box.text, and I'll simply print it. That's it. If I know, so the beautiful thing here, see, it literally prints these two. Of course, this will not work if you try today because the website itself has changed. Using pandas, do all of that. This is a very, 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 very simple example. Now, the important aspect here, let's look at what we have done. Okay. First thing, we obtained the page using URL lib2. We knew what data that we want. We wanted the stock symbol. We wanted the stock symbol and the stock price. We went through the structure of the HTML page itself using the inspect element, on Chrome. Okay, we used this to go to the part of the source code. And of course, to actually go to the part of the source code, what did we do? We used Beautifulsoup to go to the part, and we used the Beautifulsoup.find because I know which part I have to go to because I studied the structure of the HTML code, right? Look at this here. What did I do? This whole part, I understood where the price, which part is the price stored in, which part the name is stored in, right? Since I obtained that information, I simply cut the data that I have. So Beautifulsoup literally simplified the whole task because it has this find function. If you were to do this using grep, it would have been a nightmare, trust me. Okay. So this is a very, very simple introduction to building a simple web scraper. Remember, this is an extremely simple web scraper. Okay. I will not claim that this is any complex thing. That's why I said, but this is a simple static web page, right? So we saw the logic. If you want to learn HTML, this is a great source to learn HTML. We understood what is the document object model. Please don't be afraid to learn new libraries, because if you do not use Beautifulsoup, building a simple web scraper will take you many, many hours of effort using basic grep. If you Google search for it, if you just Google search, okay, let me show you that Google search, right? If you say, I want to build a web scraper Python, okay, the very first thing that you'll get, just go here, just keep reading. I've read like 10, 15 of these, right? Just to see which is the best and most simple source. Look at it. Everybody uses Beautifulsoup 4. This guy is using Beautifulsoup. Of course, he's using a slightly different library called requests to get your HTML pages instead of URL lib2. So let's look at the second guy. Okay, this is what we are using anyway. This is not something that we're using. So look at some other blog, right? In this blog, he's also using Beautifulsoup, right? So if you keep seeing, if you see 5 or 6 results, and if everybody is using the same library, then certainly that library must be super good and super useful to achieve your task, right? So this is an important lesson, that don't be afraid to learn new libraries as and when you need them. They will simplify your life. Simple Google search, going through function references and reading through examples and experimenting, not fearing of the failure, will help you learn very simple stuff, right? So we also saw some simple Beautifulsoup, the code that I've already posted here. Next comes an important part. What if your website is dynamic, right? Which means your website has HTML and JavaScript, and the JavaScript actually executes in the browser. So what am I doing with urllib2? Look at what I've done earlier, right? With urllib2, right? So sorry, let me just go here. Okay, with urllib2, okay, with urllib2, okay, I literally, this code page is here. I literally obtained this web page from the server. So when I obtain, so what should I actually do? There are two parts. First, there is a web server and there is a browser here, right? What typically happens in the first step, I obtain the page. In the second step, I execute the JavaScript here, right? So in this case, in the previous instance, I just obtained the web page. I didn't run any JavaScript anywhere, because to run the JavaScript, I need some libraries and some tools that the browser internally has, like your Chrome browser, right? Or your Firefox, right? Or your Internet Explorer, or your Safari, right? So all these browsers actually have a JavaScript executioner, or basically a toolkit using which it can execute JavaScript libraries. urllib2 does not have it. So in the previous instance, what we did was we only obtained a page. We didn't run the JavaScript to actually see the whole actual output web page. So if your web page is dynamic, which means it contains both HTML and some JavaScript, and the JavaScript needs to be executed on your browser so that you get the final page, then the urllib method. So then this method of just obtaining the web page is not sufficient, right? So what we need is both the steps. First, obtain the web page, execute your JavaScript. How do I do this? Okay, once I execute the JavaScript and I get the whole source, Beautifulsoup still is there. I'm not denying that. The first part is where the problem is. The second part, third part, fourth part, everything is the same. It is the first part, which is I'm just obtaining the page, but I'm not running the JavaScript. How do I solve that problem? You already have a browser, right? Your desktop or laptop already has a browser. Why can't I simply use the browser to execute the code? So there is a library, or there is a toolkit you can think of as called Selenium. Many software engineering testers, okay, many software engineering testing guys, okay, know Selenium, because Selenium is basically, again, you can write Selenium code in Java or in Python. Obviously, I would choose Python because I'm more conversant and comfortable in Python. And actually, Selenium code is in Python is actually easier to write than Java, to be honest. Just a second. Okay. So if you're writing Python code, of course, Selenium can be written. Again, what do you mean by that? What it means is you have some libraries, or you have a module which you can write, which you can access in Python to be able to do it. So I'll show you literally a 2-line code. Okay. So this is literally a 2-line code. Okay. Okay. So let's see. This is literally a 2 or 3-line code to scrape a dynamic web page. Okay. So what do I do? First thing is, from Selenium, import WebDriver. I'll explain you what this does exactly. Okay. From Selenium, import keys. Some simple importing stuff. Here is the crux. Suppose if this is the I'm sorry. Suppose if this is the URL that I want to grab. What I'm doing right now here in this few lines of code. So let me just zoom this in so that it might be clear. I'll provide a link to this page also. This blog is pretty good. here, I've imported the Selenium libraries that I need. Here I'm creating a Firefox session. Look at what I'm doing here. I'm saying I want to create a Firefox session. Literally, Firefox is there on my laptop or desktop. I'll create literally a Firefox session and I'll wait for 30 seconds. I think this means 30 seconds if I'm not wrong, or 30 milliseconds. I'll have to look at the function reference. But what Selenium lets me do is it lets me open or start any browser of my choice. It could be Chrome, Firefox, Safari. Edge is basically the next generation of Internet Explorer, if I'm not wrong. It lets me literally open any browser of my choice, get the URL that I want. It will also help you simulate button clicks. I can literally click on a button, right? So suppose if I want to scrape Google, don't try to do that. Google will block you very quickly. Okay. So I need to enter some search query, press enter, then I'll get a bunch of results. And if I want to scrape these results, what Selenium lets me do is Selenium lets me open a Firefox window. Selenium helps me open a Firefox window. Give it the URL that I want, wait for a while, enter whatever I want in a field, press the enter key. It'll get some result. That result, it'll give me the page. It'll give me this page after running both HTML and JavaScript. Because look at it, what is Selenium doing? Selenium is literally using the Firefox browser. Firefox browser internally has libraries and toolkits to execute JavaScript code. So by using the browsers that I already have, Selenium gives me humongous amount of power, especially for dynamic web pages. Okay. In addition to just 1 and 2, Selenium also helps you do actions on web pages. Actions like button clicks, right? It'll enable me to do button click, right? It'll enable me to enter something. Like I know that it's very simple to write Selenium scripts where you can give your username and password. Selenium code can actually enter them, log into your Gmail, scrape the Gmail page, obtain all the information that is there on the Gmail page and present you on your own app. It can do that. Okay, of course, you have to be careful that Google might block you if you try to do that too often. Okay, but it's possible to write some code like that, right? So Selenium is the trick. Again, Selenium is a huge library. People spend a lot of time becoming experts at Selenium. But for our use case, you just have to know the basics of Selenium. Those 4 or 5 lines are all you need. In Selenium, all you need to know is how to use a browser. The moment you use a browser and you obtain the data using the browser, because the browser internally has a JavaScript toolkit to execute JavaScript, you got your HTML page and you have your JavaScript. Finally, you get the result. This result, you can now pass it through Beautifulsoup and obtain whatever data you want, right? So basically what we have done using Selenium, we have replaced urllib2 with Selenium, right? And the reason for doing that is Selenium can execute JavaScript. It can also help me perform actions which urllib2 cannot do. urllib2 can just simply get me the HTML source because it doesn't have a JavaScript executor, right? So if you want to do dynamic websites where there is JavaScript components that need to be executed in the browser, Selenium is the way to go. But don't be fearful of Selenium, right? It's not rocket science. If you want to perform something, if you don't know, just Google search for it. It's just a Google search away. That's how I learned Selenium, by the way. So my team, of course, not me, but a bunch of very smart engineers in my team actually use Selenium to crawl a large number of web pages on the internet for some internal project in my own team, right? So, and what we literally did was we used Selenium. It's a terrific piece of software, or terrific piece of libraries, as I should call it them, right? So there is a third aspect which I did not cover here, which is websites that obfuscate, websites that constantly change, to avoid scrapers from pulling information from them. This is a very interesting challenge because, for example, we saw just now, right? When we went to the Bloomberg page, right? The name of the class itself might change from one request to other request. Okay, let me just show that to you, okay, so that you can better appreciate it. Okay, where is that Bloomberg page? This page, right? Okay, let me just open it again here. So let's see. So this, if I say inspect, what is the value that I get here? 2792, right? What did I get here? Okay, let me see. What is the name of this thing? Okay, it says price text. So let's write it down. What does it say? Price text. I'll just write it down here. It says price text underscore 1853 1853 E8A5. This is the whole name of the class. This last section looks to be a random number, right? I think they generated this so that scrapers, so as to make life harder for scrapers. Because I typically end up using the whole name of the class, right, to obtain this piece of information. Now, by generating random numbers here, I'm assuming it's a random number. We'll test that, right? The class name that I need to actually pull this information becomes harder. Okay, so let's see. So we have this name. Sorry, where is this? Okay, we have this, right? So let's go to a new page. Let's go to this again. I refreshed the page here. Let me inspect it. What will I get here if I inspect it? What would I get here? Okay, so no, the name is the same. Okay, so they're doing some form of randomization, not exactly randomization, but they keep these names somewhat random. So a lot of websites, what they do here is, because they want to avoid, so they want to avoid their people, they constantly change the names of the names of your div or names of your headers. They constantly change and make the whole page extremely dynamic so that scrapers can't obtain them. This is an extremely hard problem for which, again, there are multiple solutions. It's like a cat and mouse game. Okay, it's like a cat and mouse game where one person tries to do one thing, the other person tries to do the other thing. So I hope you got a sense of how web scrapers work. Again, to be honest, I have not gone into too much depth. This is just an introductory session. I hope going through these links and following the methodology where you're constantly writing the problem, writing the logic behind problem and Google searching can certainly help you, right? So let me just add this HTML thing here so that when I share this document, it will be much easier for everyone, right? So yeah, so I'll go to the live view for a few minutes that we have now. Okay, so let's just see what comments we have. Okay. So how to know whether a page has JavaScript or not? Obviously, you can run the code through Selenium, and you can just get URL lib and see if the HTML code is different. Very simple check, right? You can also get data using get of URL. Yeah, so you can always do that. Obviously, get is another way, like URL lib. There are many ways to get a web page. URL lib is just one method of doing it. Oh yeah, so the question here is, can I scrape JavaScript rendered web page without using Python Selenium? Yeah, there are ideas called, there are some advanced methods wherein you don't require to actually start the browser itself. You can simply get the whole source code and take. So again, this is something that I know a few people have tried. What they've done is they've taken Firefox. They have broken down because Firefox is open source, right? So what they do is this. They don't have, so they make they basically retrieve or remove the functions within Firefox which execute the JavaScript code, right? So it actually executes the JavaScript code for you. And very interestingly, just a second, I hope I am live. Just checking that. Yeah, the screen is on me. So what they do here is, so they've taken the whole Firefox source code, they pull out the information, they pull out the JavaScript executing system that they want, they pass the JavaScript through that, it will result in some result. They'll take that result and use it to build the final web page. Instead of actually, because if you have graphics, right? Because what does Firefox do? Firefox takes the whole thing, renders it graphically. The graphical rendering if you're building a literally web scale scrapers and web internet scale scrapers and crawlers, right? You can save a lot of computational effort by avoiding some of this, right? So somebody's asking about Python having too much in competitive programming, taking too much time complexity. I think, to be honest, Python code is pretty decent. I know I have participated in some hacking or whatever you call it, competitive programming stuff. And Python is one of the most favored languages. Certainly, there are people who write it in C, C++, but if you write the right algorithm, using right data structures, using the right complexities, it shouldn't really matter. I mean, Python is pretty good. Of course, if you're going to internet scale, extremely critical applications, Python is slow. Like if your difference between, if it's a life and death situation, or if it's like a millisecond gap, if you want extremely low latency systems at internet scale, C, C++, nothing can even touch it. Or if you want something in embedded systems, right? So you have, let's say, a heart, an equipment which measures your heart rate or something, which needs to be which needs to run extremely efficiently on a very simple hardware, right? In those situations also, probably code is written in C, C++ and not in Python, right? So, okay, so let's go here. Okay, I'm just crawling through all the chats here to see if there's anything, because I see very interesting stuff that people are asking questions and answering there also. So that's a very good that's a very good thing. Hey, so what I'll do here is I'll provide the link to this notes right under this video as the first comment, and I'll pin that comment so that everybody can watch it. I'll just share the notes here itself so that even people who are non-registered students can also check out the PDF of this or the Google Doc version of it. So that's all I had. I think, and very nice to see a lot of students putting in their knowledge, sharing their knowledge that they have, and most importantly, answering questions back and forth. Thanks a lot for that. And I hope, see, the objective of today's live session was to teach you how to write, how to break up code and do some simple stuff. Of course, some of you may have gotten bored, but I thought there are some students who need that helping hand. That's why we did the first part. The second part is to give you an introduction to web scraping, right? Of course, web scraping is a massive area. Was just on web scraping, that would be like at least a 20-hour content, right? Because there's so many nuanced details. I have to go explain HTML first. We have to go through JavaScript next, because those are foundational stuff, right? Then we understand libraries like Selenium in lots of detail. We understand Beautifulsoup in lots of detail. So what I wanted to give you today is a flavor of the whole thing so that you can take it forward and learn, just the way we did in the last session. In the last live session, I gave you a flavor of Rasa. I also gave you some introduction to Dialogflow and some introduction to end-to-end conversational engines. And some students actually took up that feedback, those hints and the path, and actually built some very interesting things. And I hope some of you actually can build some interesting tools, some interesting scraper. So if you build a interesting web scraper or a simple scraper, please share it with us, and we'll try our best to give you some feedback on it or ways to improve it. And it's also very encouraging for us in doing these live sessions. So I think we are short on time. We are almost done. Just a couple of minutes here. I want to thank everyone who participated in this live session, both registered students and non-registered students. I hope this has been at least partially useful, if not tremendously useful. So at least some parts of it you'll take away with you and use them in your day-to-day programming or day-to-day building web scrapers or data science or machine learning. Thank you all for your time, and it's my pleasure as always to do these live sessions. We'll announce the next live session topic. Again, next live session will be a slightly advanced topic, and for all the registered students, we'll announce that at least a few days in advance. Again, we'll try and do it mostly on Sundays and not on Saturdays, as I started earlier. And yeah, that's all for today. Have a good weekend. Get some time with family, enjoy yourself. Also, happy programming and happy coding. Thank you, folks. Bye bye. Have a good weekend.